So thanks everyone for joining us this afternoon. I hope you've been enjoying the serverless days at Cardiff. And yes, I'm wearing two t-shirts on top of each other. Don't do so well in the cold. So today I'm going to talk to you about how to save money on your serverless architecture. So my name is Yan. I've been running stuff on AWS since 2010. I don't know how many of you were using AWS back then, but there's literally like 10 different services. Now there's so many of them, you can't even scroll through them without multiple pages. And nowadays I've been spending about half my time working with Lumigo as a developer advocate, and the other half of my time I work as an independent consultant. I help other companies adopt serverless. And funny, I was talking to Matt yesterday, and he called me a human co-pilot. Because, and I quote, "I've never seen anyone code that fast." So, now you know two things about me. Another thing you should know about me is that I like to collect stories about people's AWS builds going a little bit crazy and how you can save your AWS costs, especially when it comes to serverless architectures. So I hope you enjoy drinking from the fire hose, because I've got some stories and ideas to throw at you, as Matt said. This is very much a brain dump session, and I'm going to give you lots of different ideas. Some of them may work for you, some of them may not. Some of them are fairly out there, and almost to the do not try this at home territory. But let's start nice and easy. Billing alarms, something that everyone should be using if they're going to be using AWS. Billing alarms are not perfect. They are usually a couple hours behind real time, but it's better to find out that you've got a problem happening, say a few hours late, than a few days or a few weeks late. And Luke, who was up here earlier, had a really good story where, so his team was maintaining a bunch of different Lambda functions, and they made a one-liner mistake in one of the functions, which broke the caching, so that on every single invocation, they were calling secrets manager, which, and before they were caching, but this one-liner change broke that. So Secrets Manager charges you, $5 per million requests, and if you're making hundreds of billions of requests, or some millions of requests to Secrets Manager, then that cost can pretty quickly build up. And because they set a billing alarm at 2,000, so they found out after maybe about 10 days or so, and when the billing was at 2,000 as opposed to, say, 4,000, if they didn't have the alarm in place and only found out when they got the bill at the end of the month. So the morale of the story is that, yes, billing alarms are not perfect, but you should still have them so that when something does happen, and they will, because you can't possibly find all the mistakes that one can make, and you can't possibly test every single thing your application is doing. And so having billing alarms is a good safety net to have for everybody. And so mistakes are expensive, but talking about things that are also expensive, unfortunately nowadays the objective experience for many application builders is that when it comes to observability, it's both expensive but also bad. And given where we are today, I'm sure that's also how you feel about places like London. That's kind of the reason why I'm living in Amsterdam, for one. And so, when it comes to observability, especially for serverless applications, I find that oftentimes when I look at my clients' AWS build, CloudWatch is often in the top 3. And in fact, when you look at Lambda functions, oftentimes they are really cheap in comparison. So you often find that CloudWatch is much more expensive compared to the cost of your actual application. And what's you guess is that, the more you're logging, the more you're collecting, the less or the harder it is for you to find that needle in a haystack, because you now have a bigger haystack to search through to find information about what actually happened. There's a couple of things you can do to help keep your CloudWatch logs costs under control, or to something that's more reasonable. One thing you want to do is to make sure that you are doing structured logging. So anytime you're writing a log message in your application, think really carefully if this should be a debug message, it is information, some general information about what's happening in your system. If it's an error, but it's not fatal, we can just recover and continue, then that should be a warning. But if it's an error that we have to abort and return a 500 to the caller, then that should be an error. And then in production, when you deploy your application to production, set the threshold for the log level to something more reasonable, at least info, so that you don't have all those millions and millions of lines of debug messages that are not typically useful. However, when something does happen, and you do need to figure out what was the problem, and you do need those debug messages. So you also don't want to be in a situation where you don't have any debug logs in production, and you have to then re-enable logging at the debug level, redeploy, wait, cache messages, and then roll back. So what you want to do instead is to sample your debug logs for, say, 5 or 10% of user transactions, so that you should hopefully have enough debug logs to cover every single code path you have, but not so much that you end up paying a lot of money to CloudWatch and you're not getting a return on investment on those spending. I'm going to say this multiple times today that I don't mind spending money, but I want value. Whatever I'm spending on should deliver value. I hate paying for things that doesn't give me any value, and also one of the reasons why I don't like paying for uptime, why I love serverless so much that I only pay for what I use. Another thing you want to do is make sure that your log retention is set to something reasonable, like 30 days. By default, CloudWatch doesn't delete your logs. Retention is set to never expire because AWS doesn't want to delete your log messages without you saying so. But your log messages are going to have less value the longer it goes. And since they charge you also for retention, so the more logs you have and never delete, that cost is just going to go up and up and up every month because it's cumulative. Many of you may also, like myself, find that searching logs in CloudWatch is not the best experience, and so you ship your logs to some other vendor instead. And many of you will probably be doing that with a Lambda function that listens to CloudWatch logs events, and then take them and send them to, say, Logs.io, Datadog, or whoever. And so in that case, you're going to be paying for processing for those logs in CloudWatch, but also the Lambda invocations. And chances are, whichever vendor you're working with, they also charge you for ingestion and storage and whatnot. So you end up paying for processing the same log messages, well, twice at least, so that you're paying for CloudWatch and also at the vendor. Nowadays, there's a better way to do that, because with Lambda, you have this thing called the telemetry API, which is an internal API that's exposed to Lambda extensions that allows the extension to listen to log events and other things so that you're able to then collect them, and in the extension, send them directly to the vendor. So that way, you can ship those Lambda extensions as a layer to a Lambda function. They will subscribe to the telemetry API and collect those log events and then send them to, say, Logs.io or whoever, without you having to go past the CloudWatch logs first. And once you have that in place, you can then update the IAM permission for your Lambda function to say, now, please don't give any permission to create log groups or write logs to the CloudWatch. That way, you can disable Lambda from being able to write to CloudWatch logs. Unfortunately, there's no setting to say, please stop logging to CloudWatch. So to do that, you kind of have to modify the Lambda function's IAM permissions to stop it from writing to CloudWatch logs, and therefore stop paying for those logs being ingested and processed by CloudWatch. And if you're thinking of moving away from CloudWatch and you don't know where to go to for your logs, there's also Lumigo. Check it out. They've got a pretty good log support for logs, especially for Lambda functions, but they also support the containers, the EKS, the ECS as well. So going back to CloudWatch logs for Lambda, you also have these system messages. For every single invocation, you're going to have like a start message, an end message, and a report message that says how long it took, how many milliseconds that you end up paying for. For most of you, this is not a problem. No, just a few lines of messages for every invocation. You're not going to have that many invocations, so this doesn't create a big problem. But if you've got a system that have to invoke Lambda functions for billions of times a month, such as the guys from Fathom, then those small log messages can build up pretty quickly and to something that you may think, well, that's $1,000. That's paying for someone's salary. So you're going to want to look for ways to maybe don't pay that. And so again, I don't mind spending money, but if those log messages don't give me any value, I don't want to spend money on those. Nowadays, you can stop that with the new, well, maybe not new, but advanced logging controls with Lambda, which give you an option to configure a logging config object in CloudFormation, and also CDK, SAM, and so on. What's annoying, though, however, is that you have to set the log format to JSON. By default, CloudWatch just captures whatever logs you send from, well, whatever you write to send it out as a string, as a text. But when you change the log format to JSON, Lambda will also take your standard out message and wrap them inside a JSON structure, just so that DevOps teams keep complaining about developers don't write structured logs, and we have a hard time structuring those messages and send them to some log system. That kind of solved that to some extent, but once you set the log format to JSON, you can also use the system log level to say which of those system messages Lambda should emit to CloudWatch. And so if you only want to see, say, the init report, and maybe when there's a unhandled exception, you can set the log level to info. Or if you don't want to see any of that, you just want to know when your function has an unhandled exception and log the stack trace, then you can set it to warn, in which case you don't have all of those debug messages from Lambda service every time your function is invoked. So CloudWatch is one of the most, the fundamental services that everyone should know how it works, even if you don't end up using it for searching and storing your logs. So I want to give a quick shout out to Sandro and Tobias on finishing the CloudWatch book, so that you can learn all the different things that CloudWatch can do for you, even if you don't use it day to day. Another thing talking about the Lambda is that probably the most common way that you want to optimize the cost for Lambda function is to make sure that you choose the right memory size for your functions. Because when it comes to Lambda, you have one single dial or lever to control how much memory and how much power, CPU, and the bandwidth your function has, but also how much duration time that it's going to cost you. Because the more memory you allocate to your function, the more it's going to cost you per millisecond of execution time. And that's kind of great that you got this one simple lever to choose to say, okay, I need to do something more CPU intensive. I need more juice. Let me just give my function more memory and therefore more CPU to process things faster. But it's also easy to get things wrong by an order of magnitude by mistake. So I want to tell you a quick story about a client I was working with a while back. So they do video rendering. So they have all these hand-drawn videos you've probably seen on YouTube. So they've got a Lambda function doing a lot of those rendering. And they think, oh, this thing is taking quite long. We want to make it faster. Let's give that function more CPU by allocating more memory. And so they know, okay, Lambda allows you to allocate up to 10 gig. So let's just dump all 10 gig on the function. That should go faster, right? It should, but what it didn't think about at the time was that when it comes to Lambda's memory allocation and CPU, once you go over 1.8 gig of memory, you start to unlock a second CPU core. At 10 gig, you actually have access to 6 virtual CPUs, and that's great. That's a lot of parallel processing you can do if your applications are written in such a way to take advantage of multi-core. They were using JavaScript and Node.js, and they didn't write the application in such a way that can take care of multi-core. So again, they were having the right idea, but they just didn't think about some of the nuances. So in that case, they actually spend, paying for 10 gig, but only getting the benefit of 1.8 gig. So most of what they were spending was going to waste. Again, I don't mind spending money, but I want value. If I'm spending on something that doesn't give value, I want to change that. So for them, I think this Lambda function ended up costing about $10,000 a month. And then when I came in and helped them, I identified, oh, that's a problem, and they're able to save a majority of that cost. So as the great Donald Knuth once said, 97% of the time, we should forget about small efficiencies. But for that critical 3%, once we identify where we can get some return on investment, we should definitely go ahead and do that. If I go to the Lumigo console, I can quickly find all my Lambda functions in my account, and I can sort them by estimated cost. So in most environments I've seen, Lambda costs are fairly low. There's not much you can actually gain by optimizing them, but you often find that there's maybe one or a small handful of functions that accounts for most of your cost. So for that particular example, with a client, you're able to quickly sort the functions by cost and see that as one function that accounts for majority of your cost. And so in terms of identifying the function, you know which functions is over-provisioned in terms of memory, and you want to save some money and right-size it, then you can use the Lambda power tuning tool, which is step functions that takes your Lambda function, creates multiple copies of it with different memory settings, execute it a number of times to see how does the cost and performance changes as you allocate more memory. So you may find that, okay, as you allocate more memory, function gets faster. And since you're paying for per millisecond of execution time for Lambda, so you may end up being cheaper to run on a higher memory because it's running faster. But that's going to plateau at some point because once you go over 1.8 gig, again, you need to write the application in such a way to take advantage of multi-core. And if you don't, then you're not going to improve the performance. Your cost is just going to keep going up instead. Another way to improve the cost of your Lambda functions is to use ARM instead of x86 because the per millisecond cost for ARM Lambda functions is about 25% cheaper. But keep in mind that even if it's 25% cheaper per millisecond, if we end up running for much longer than that, then you end up paying more as a result. And in terms of performance, when the Lambda team published a blog post to say we support ARM, they cited some numbers, something like, I think, 30% more performant, but also 25% cheaper. But when I tested it on some of the workloads I had, I found that in the worst case, an ARM function doing the same thing is over 60% slower than the x86 on doing the same function. So you end up saving 25% per millisecond, but spending 60% more time, so you end up paying more for that function in the end. So if you want to think about doing this, run against your workload first, make sure that your function is going to perform relatively well on ARM versus x86. But what this is really, good for is when you've got functions that have to wait for something to come back. Not name any names, Salesforce. If you have to talk to vendors that take a really long time to return, then you're just spending most of your CPU time just waiting. So in that case, take ARM and take your 25% saving for free. Another thing, and this is probably the cardinal sin I've seen people make when it comes to working with Lambda, is the synchronous Lambda to Lambda invocations. When it comes to Lambda functions, there's only one way to run them, which is through the invoke API. And when you call the invoke API, there's an important attribute or choice you have to make whether to call the function with a request response. Therefore, synchronously, you call the function, the Lambda API to invoke, you wait for the function to finish running, and then you get the output back. Or you can invoke the function as a fire and forget to say invocation type is event. So you call the API, invoke the function, it runs, but that's happening in the background. You get the API call comes back straight away. And so there's a difference between the synchronous and the asynchronous, and we're going to talk about some of the nuances in a minute. But just keep in mind that I think as a rule of thumb, you should always avoid synchronous Lambda to Lambda function calls. And I see this oftentimes when people are coming, I guess, new to Lambda and thinking about Lambda in the same way they think about Lambda in programming language terms, in terms of that modularity and whatnot. And one of the problems with Lambda to Lambda synchronous calls is that the first function is going to call the second function, and you have to wait for it to finish, right? So you're paying for the duration for that second function to run, but also for the first function because it's waiting. So you're double paying for the execution time. And again, I don't mind spending money, but what am I getting in terms of as a return investment for the execution time for paying them twice? So if within the same service boundary, you've got a Lambda function calling another one synchronously, then don't do it. Just take whatever you have in those two functions, merge into one function, and you can still have modularity just inside your code. A Lambda function is a call Lambda function, but it doesn't have to be sort of used in the same way that you use Lambda functions in programming language in general. You can still have modularity inside your code without making them separate infrastructure components in your architecture. So synchronous Lambda to Lambda invocations is always a bad idea, but in the same service boundary. But what happens if you say, okay, I'm not going to do that in the same service boundary. We're going to use it as an interface to our service. We've got some capabilities that other teams want to use. We're going to expose them a Lambda function they can call. What about that? Also a terrible idea, because what you're doing is you're making your consumers depend on implementation detail. The fact that you're using Lambda at all, or what region you're running in, what's the name of your function, all of those things are implementation detail that your caller shouldn't have to know about, and you should be able to change those things without affecting your caller. So if you've got some capability that you want to expose to another team, give them an API to call so that you can still have Lambda function behind it if that's how you want to deploy your business logic, But at some point, you may find that, oh, we started with 5 requests per second. Now we're doing a steady rate of 1,000 requests per second. Lambda is no longer the most cost-efficient way to run this workload. Let's take that workload and run it in a container in Fargate instead. Well, you can do that because your customer doesn't depend on your Lambda function. Your interface is HTTP API. So, they're no longer depending on implementation detail. Instead, you've got a stable interface that they can call. You can make those implementation detail changes without affecting your callers. Okay, so that's synchronous lambda-to-lambda invocations, but what happens if you have, say, a lambda-to-lambda asynchronous invocations? Is that a good idea? I think with async lambda-to-lambda invocations, there are some legit use cases, and one that I use quite often is when I've got a user-facing API function, and I want to return as quickly as I can. So the customer wants to, say, update their profile. So I have to take the request, update the database, but then I also want to do some other things, like doing some analytics tracking, maybe some other stuff as well, maybe call Salesforce, and that's kind of take 5 seconds or whatever. But I want to return to the caller so that they don't have to see this buffer phase and just, oh, your app is so slow. So to preserve user experience, I can offload that secondary responsibility to a second function and invoke that function asynchronously, and therefore, it's going to run in the background, but the first function can return to the caller right away. So this is going to help me improve my user experience, even though I'm paying for another Lambda invocation, but it's giving me something in return in terms of improving the performance and user experience for my application. But also importantly as well, if something goes wrong with that second function that's talking to Salesforce, oh, they timed out after 6 seconds or what have you, then that can be retried independently without affecting the user because, well, we already responded to the user's API call. We are just retrying a failed call to Salesforce, for example. So that is assuming that you're doing this inside the boundary of one service, so that you are just taking what you would have done inside an API function in the first place, but you're separating some of that logic out so that once you've done your primary job, you can return to the caller quickly. Again, even if you have async lambda-to-lambda invocations and it's going across service boundary, it's still not a good idea because the lambda function is not an interface to your service. And so, async lambda invocations, async lambda-to-lambda invocations, okay. It kind of really depends. And one of the things I always like to think about when it comes to architecture is that when I look at my architecture, every component on that architecture design must serve a purpose. It must have some return on investment because everything on the architecture design is a cost element. It's something that I have to pay for. And again, I don't mind spending money. I just want value for what I'm spending it on. And there's also cases where you can also simplify and save money as well. Again, going back to the guys from Thatham, they had a really interesting use case whereby they got a Lambda function that ingests some event, and then they put it onto SQS queue, and then another SQS function is going to process it. And what they found was that when they just did everything in that first function, it was both faster, but also cheaper because they were able to eliminate the use of SQS queue in the middle, and therefore another thing you're paying for, as well as the second Lambda function invocation. And so by doing that, because they're running at pretty big scale, they were able to save, I think, something like about $24,000 per year by simplifying the architecture. When it comes to performance, while building large-scale performance applications, large-scale applications, but also performance applications, caching is kind of almost like a cheat code. If they can, behind every single large-scale application is a well-thought-out and sensible caching strategy. And when it comes to your typical serverless API, you can actually cache at every single layer in that entire core chain, from the front end to your backend Lambda function and DynamoDB. But typically, you just need to look at caching in maybe 3 places. You want to do caching on the client side or for things like static assets, content, and maybe some configurations. And for API responses, you can just cache at the edge with CloudFront. But if you're doing something computationally expensive in the Lambda function, you also want to cache those as much as possible. And you can do that by saving those computed results into like a shared distributed caching like Elastic Cache. But with Elastic Cache, you have to pay for uptime. You're paying for a cache node 24/7, even if you don't use them. And again, to me, that's waste. I want to keep saying this, that I don't mind spending money, but I want value. And so when it comes to serverless, I really like the pay-per-use pricing model. So nowadays, I actually prefer to use a Memento instead, which gives you a pay-per-use pricing and distributed caching for cache with this pay-per-use pricing. Talking about caching, another cache thing that we don't often think about is Route 53. And Route 53 has got a default TTL for your domain records for 5 minutes. But for a lot of the domains I've seen, they actually don't really change. They don't change from 1 hour to another. In fact, a lot of time, once they're set, they never change. And so with Route 53, the way you're charged is based on the number of DNS records you process. And if you've got a domain that is stable, you know it's not going to change regularly, then just slap on a really big TTL so that you don't have to pay for all of those requests to Route 53. Again, something to think about when you're running at a big scale, which for some of you is probably okay because you don't have to process billions and billions of requests per month. Another thing to think about when it comes to things like DNS is CORS, which is something that most of us hate to deal with. With API Gateway, to support CORS is actually really simple. You can just take a setting, and the API Gateway is going to generate those CORS methods for you, for your API. However, you still end up paying for those requests that the API Gateway handles for those generated options methods. And you may think, oh, that's an easy problem to solve with caching, right? You just enable caching on CloudFront and problem solved. However, there's such a long-standing bug in the API Gateway in the way it handles the authorization header. So if you're using authorization header, and chances are many of you are, then it kind of breaks some of the cache headers so that if you look at say your traffic in say Charles Proxy or Fiddler, then you may see that you're making multiple requests, option requests to the same endpoint, even though you got cache enabled, and it's because of the cache headers that kind of broken once you have authorization header in the mix. So there's a good chance that some of you are double paying for your API requests because those option methods are being called over and over. So in terms of solution, you can either just roll your own option method when you deploy your API, or probably where possible, you want to just avoid a problem altogether, of course. So if you have to choose between putting a subdomain like api.mydomain.com or just sticking it at the end of as a subpath of your same domain that your front end is hosted on, then go with the latter. So you don't have to, of course, to think about the first one still counts as CORS, even though it's on the same root domain. When it comes to architecting on AWS, choosing the right service or knowing which services to use is probably the most important skill for any solution architect working in the AWS space, because in the cloud, every decision you make is a buying decision, and picking the wrong service can be very, very costly. And say if you're building some kind of event-driven system or just messaging-based system, and you have to choose between several messaging services from AWS that can all kind of do the job of taking events from a publisher to invoke a subscriber, then say 1 request per second, Kinesis is looking quite expensive. One might say it's order of magnitude more expensive, but it's still just $10, $20 or whatever per month. But if you were to scale that up to now doing, say, 1,000 messages per second, suddenly the picture looks very, very different. And the reason for that is because even though Kinesis charges you for uptime for the shards, and therefore there's a baseline cost, but its cost per million requests are much lower compared to the likes of SNS, SQS, and EventBridge. And so at a higher scale, Kinesis is much more cost efficient compared to some of these other services. And the same dynamic plays out when you're talking about having API Gateway versus ALB. ALB has got a complicated metric of working out what's the cost dimension for your API, but at low throughput, like 1 request per second, is much more expensive compared to API Gateway. But then again, the pictures changes drastically when you scale that up to, say, 1,000 requests per second consistently as like a baseline. Suddenly, ALB can be much more cost efficient. So a good rule of thumb to have when it comes to architecting on AWS is that at scale, services that charges you on uptime is likely to be much more cost efficient. However, it's important to always look at the specific cost dimensions of the services you're working with, because earlier I was assuming a payload of about 1 kilobyte. What do you think happens if we say, well, our API is handling a big load, average payload size is 1 megabyte? I'm going to give you a second to formulate a number and see how close you get to this. Because when I put this through to the AWS calculator, well, it actually doesn't look great there, does it? So always think about the specific cost dimensions of the services that you're working with. And at the last re:Invent, Werner gave us the frugal architect and the 7 rules for us to follow when it comes to architecting on AWS. And I really like specifically these 2, where it says architecting is a series of trade-offs. And also, we want to build systems whose cost grows in the same dimension as our business revenue. So as our revenue grows, our cost grows in step, so that our cost is not going to grow out of line with our revenue. And this is important, for example, because I've built multiple WebSocket-based applications on the AWS using serverless technologies. And on the AWS, you've got multiple services that gives you WebSocket, without having to manage the WebSocket server. And they all charge you based on the number of messages you process, or rather you send and broadcast, but also for connection time. So how many devices are connected to the WebSocket connection, and how long are they connected for? And if I was to build, say, like a social network or something where I want to send the push notifications to the users, and the more users I have, the more connection time I'm going to have as well. But what happens if my revenue doesn't grow with the user directly? Instead, it grows with how engaged the users are. Therefore, how much activities they're doing on the system. Are they posting regularly? Are they liking other people's posts? So if the revenue grows with user engagement, then I also want my cost to grow with the activity, not with the connection time. Because they may have lots of users, but they don't do anything, and they don't want to spend money on things that they don't actively engage with. And so I want services whose cost is going to grow along the same dimension as my business revenue. And again, Memento's got this really nice topics system, which gives you WebSockets out of the box. And again, it's all serverless. And the nice thing about their solution is that they don't charge you for connection time, only for the number of messages that you send and broadcast and whatnot. So when it comes to building a system that whose business revenue is going to grow with engagement and activity, I want to work with systems that is serverless for one, but also whose cost is going to grow in the same dimension as my business. And speaking of picking a cost-efficient or cost-effective partner to work with and build your system with, anyone who uses Vercel probably saw this story a little while back. This social network which was funded and run by volunteers, blew up. They went from 0 users to about 500,000 daily active users in the space of about 3 days. And then happy days, of course, but then they also got a bill for about $100,000 from Vercel because of overusage. And the reason for that is because Vercel is built on top of AWS, and so they put a markup on anything that you consume on the AWS account. And of course, that markup, unfortunately in this case, is something like 7 times of what you would pay if you were to run your application on the AWS directly. So it's all well and good that you will still have to pay for something, because to grow from 0 users to for 500,000 daily active users, that is amazing growth, and you are going to spend money to make sure that kind of growth happens and you don't run into scalability problems. But the amount you end up paying depends really much on the kind of technology that you decide to go with. And since then, they also introduced some additional cost dimensions for, I think AJ reported that now they even charge you for draining your logs from Vercel to, say, some other platform. So when it comes to Vercel, be really careful in terms of what your traffic looks like and how much you end up paying. They do have some cost control measure limits, so make sure that you look at those, enable those if you're working with Vercel. I guess another one that you want to talk about often, and I touched this earlier as well, is that another move you also want you can employ to reduce the cost or make it more cost efficient is to simplify your architecture. And I think I mentioned this before, that I want to avoid having unnecessary moving parts in the architecture, because everything in the architecture is another cost point, another thing I have to think about in terms of scalability, in terms of robustness, in terms of cost. We talked about earlier how if you've got Lambda functions that are doing synchronous calls and another Lambda function, then just simplify and combine them into one single function. But also talk about how async Lambda calls can be okay sometimes in the right use case. But I sometimes see in the customers is that, well, a lot of them read my blog posts and know that I'm really against the Lambda calls, specifically synchronous calls. So they end up doing this. Oh, we're not doing asynchronous, we're not doing Lambda calls. That's a SNS topic in the middle. So this is what I often like to call async Lambda to Lambda invocation masqueraded as event-driven architecture, just so that Yan is happy with you. Because when I talk to them, they're like, oh, do you ever need to fan out the message to other targets? No, this is just so that we can avoid having Lambda to Lambda function invocations because you told us it's bad. Well, you got a message, but not quite the meaning behind the message. And so if we are just doing that to avoid having a Lambda to Lambda invocation, and it's all within the same service boundary, then again, just simplify by having the first function calling the second one, assuming that you're doing that for good reasons, such as the example I talked about earlier, where you got API function, want to return quickly, and so offload some of the work to a background function to do asynchronously instead. And the nice thing is that when you do this, you get all the benefits of going through SNS in the first place, because you got built-in, this is an async invocation, so you still get a built-in 2 retries out of the box, and you still get support for DLQ or Lambda destinations in case, after 2 retries, things still fail. So you have all that goodness in terms of building more resilient systems without having to pay for also SNS in the middle as well. Every component in your architecture must serve a purpose and must deliver a return on investment because it's a thing that you got to pay for. And so don't just keep doing the same thing over and over, because that's the pattern that we've always done this. We always use SNS with SQS and then Lambda function between 2 Lambda functions. So always think about what it is that you're doing right at this moment and think what's the best way to do this. And if I was to do this approach, am I actually getting value from those extra components and moving parts in my architecture? So, talking about removing unnecessary moving parts from the architecture, one thing you can do nowadays with Lambda is you don't need API gateway or ALB to create a serverless API anymore. You can have just a Lambda function expose itself to the public in a good way using function URLs, so that people can invoke your business logic in the Lambda function without having to run the API gateway first. So this is a good use case, you say, because you're not using all the features that API gateway gives you in terms of things like request models to validate post bodies, or using direct integration to call other services, or you're not using cognitive authorizer, for example. Or maybe it's the case that you're hitting limits with what API gateway can do, such as you've got the 29 seconds timeout, and you are doing a Gen AI chatbot, and the model takes more than 29 seconds to come back to you, and you want to do response streaming, which you can't do through API gateway. So again, that's a good reason to instead look at the function URL instead. The downside with using function URL is that now you have to write your function as a lambda lith, which is basically a lambda function that handles all the different API routes inside the code, as opposed to using API gateway to route to different functions, one for every single endpoint and method. So there's legitimate reason to writing lambda lifts in terms of simplicity and whatnot, but just be mindful of the downsides as well, that you don't have per endpoint or method alerts, as well as metrics, and as well as the ability to use different authentication and authorization mechanisms for different endpoints. All of these things can be implemented by yourself, but those are things you have to then do yourself and own the solution. And also, some of the frameworks you may use for Lambda lifts, like your Python Flask or Express.js or whatnot, many of them are not designed for Lambda, and so they can have a big impact in terms of your code start time. What I do find is that lambda lifts is, function URL is great for internal APIs or just purely public APIs, because it gives you 2 authentication mechanisms out of the box, either completely public or using AWS IAM, which is great for building internal APIs that are meant to be consumed by other services in your system. But if you do need to do user-facing APIs, you can also do that by just having your Lambda function validate the Cognito token itself as well, which turns out is pretty fast. 4 milliseconds for the first time, and then you cache it, and after that, it's actually pretty quick after that, about sub-milliseconds response time. So it's perfectly viable to do that as well. We can also go completely the other way by, instead of removing API gateway from our serverless API, and we will remove the function instead and go functionless. So this could be a case, you've got your API gateway, Lambda to DynamoDB, and all I'm doing is just simple CRUD. I'm taking whatever comes in the request body and just saving into DynamoDB without doing any business logic or custom transformation. So in that case, API gateway can actually do that for you without you having to write a custom Lambda function. And so no Lambda means no cold start, right? Because API gateway is just taking what you have and calling the SDK to put stuff into DynamoDB on your behalf. And also, no cost associated with invoking and running a Lambda function just so that you can call the SDK to do a write against DynamoDB. And this is not limited to APIs as well. So you have your API gateway directly integrating with DynamoDB to put something into the table, and then you can use that to trigger some further processing and transformation. Because I want to turn user calling my update profile API endpoint, and I'm saving it, I'm updating that profile in the DynamoDB. I want to turn that into a domain event like user profile updated. So I can then have event bridge pipes connect to the DynamoDB stream, and use the Lambda function to transform the event so that it doesn't look like a database row updated the event, but actually looks like a domain event, and send that to EventBridge. So another good rule of thumb to have is that you want to use Lambda functions to transform data, not just to transport data from one place to another without doing anything to it. And so you can have that simple setup to then go all the way from the taking API endpoint request to turning them into domain event in the event bridge. And after that, you can also have the step function and other things as well. So I also have here, you can also synchronize data from DynamoDB to OpenSearch nowadays without writing custom Lambda function. There's the no-code ETL, and there's also other services like AppSync and step functions that also support ability to integrate directly with other services without you having to write a custom Lambda function all the time, because every component in my architecture must serve a purpose. If it doesn't, then think about, can I do without that component altogether? And taking that idea to the extreme, what if we also just let the client talk to AWS resources directly without having anything in between? So instead of having API gateway, Lambda, just so that the front end can talk to the database to get some data, what if we just let the front end talk to the database directly? And before you call me crazy, you can actually do this safely as well and securely. The way you do that is having the front end first authenticate against Cognito, so you get your job token back, and you can set up a Cognito identity pool, which is then linked to this Cognito user pool, to then take the job token you got from Cognito user pool and return a mapped IAM role, a temporary credential for that IAM role that allows the user to access just their data in DynamoDB by making sure that in your IAM profile, document for the Cognito user pool authenticated user role, that in the DynamoDB table, your primary key matches the sub or subject ID for your user incognito. So this way, the temporary credential you return only allows the user or the front end to access their data in DynamoDB. And you can do the same trick with, say, S3 and other services as well, which allows the front end to directly interact with your backend services. In fact, this is kind of what you have to do when you come to building IoT solutions that allows the IoT devices to talk to AWS services directly. So you can take this idea and use it to build APIs and other things as well. But of course, this is kind of risky. It's definitely not for the faint of heart. In fact, I would say there's probably like 100 different reasons why you shouldn't do this at all. This is very much the don't try this at home kind of thing. but it's also high reward, high risk, high reward. So if I was to say I'm building a new project, a side project, I'm bootstrapping it and I'm paying out of my own pocket, I want to be really extreme, and instead of having architecture that, or rather engineering principle that optimizes for avoiding mistakes people are going to make, I'm going to have an engineering principle that optimizes for cost savings. So I'm going to do the most I can to save cost. So this is an idea that you may want to do in those situations. Again, you can do it safely and securely if you know what you're doing. I blog a bit about it more, more in detail in the blog post. This exercise is available afterwards, so you guys can always check it out. And so those are 12 moves or ideas you can use to improve the cost efficiency of your serverless application. There's a lot more where that came from, and I hope you got your phone ready because I'm just going to flash this in a minute. Oh, what happened there? Well, I guess you just have to come back next year to Cardiff to find out 8 more tips about how to save money on your AWS architecture. In the meantime, if you want to learn more about building serverless applications, I've got a workshop coming up in November. So yeah, check it out. And thank you so much for having me this afternoon, and I hope to catch you guys again soon.